Hey everyone, we're gonna get started pretty soon. Let me just put the link for Replit in the chat. Okay, so remember to open your same project from yesterday, or you can start a new one if you like. But the thing is, if you have a free account on Replit, you can only open up to 3 projects. So eventually you'll have to copy over all your text and then save it to your computer so that you can edit the project. Okay, but for today, I'm going to work from the same project on my end. So yesterday, we talked a bit about static methods. And today, we'll just talk a bit more about methods, and then I'll walk you through a few projects. And then at the end, we'll be doing some homework. Okay, so yesterday, we talked about how to use a method, like what's the syntax for a method, and how to call a method. But today we're going to learn why you would actually use a method instead of just writing everything in the main method. Okay, I'm actually going to clear everything for today's demonstration. Okay, so when should you use a method and why? First, let's talk about what an algorithm is. You may have heard this word before, but it kind of just means a list of steps for solving a problem. So, in programming, when you had to solve a problem, like write a program to solve a problem, you're basically writing an algorithm. And for example, we can have an algorithm for baking cookies just in real life, which is like a series of steps. And the steps might start with, oh, you mix the ingredients, and then so on until you end with the finished cookies. But the problem with writing out all the individual steps like this is that there's not really any structure. So, looking at these, there's a whole lot of steps, but each step is one singular action, and sometimes the actions kind of repeat. Like, for example, if you're trying to make 2 batches of cookies, then you'll see that you have to repeat a few steps. However, if you make a structured algorithm, then that's what we call splitting a few, or I should say, grouping every few steps into a coherent task. So, for example, you can have mixing the ingredients, preparing the butter, beating the eggs, and then stirring those ingredients together. We call this making the cookie batter. And what we've just done is group these 4 tiny steps into a larger step. And so later, when we're looking over this algorithm, we can see all the larger steps, and this gives the whole thing some structure so that it's easier to tell what we're doing. And then the other benefit of grouping smaller steps together into larger steps is that we can then remove the redundancy. What does this mean? If we ever want to do something twice, then we don't write all the smaller steps a second time. Instead, we just write the larger step a second time. Like, let's say you defined baking the cookies to mean these 4 steps. Then, if you just tell someone to bake the cookies again, they already know to refer back to the same 4 steps. So you don't need to write these 4 lines again. So what does this mean in a programming context? Let's say we're writing a program to print out the steps of baking a cookie. So I'm going to copy this over to Replit. So right now, this program is quite messy as it is because we just see a large wall of text and we don't really know what are the main steps. So there's actually several ways we can make this program look cleaner. One way, of course, is to group every few steps into a method. However, some people might think of, oh, I'm just going to add comments to make the program cleaner, which you could do. So I'm going to demonstrate doing that first. So well, there's an extra indent here, which I'm going to remove. Okay, never mind. All right, so the first 4 steps are part of making the cookie batter. So I could use a comment to specify that. And then the next 4 steps make up the larger action of baking the cookies. And then the next 4 steps are, as you can see, on line 9, we have set the oven temperature. And then on lines 14 through 17, we have the exact same content as 9 to 12. So we are baking the cookies again. And then the last 2 steps are called adding frosting and sprinkles. So as we can see, this program looks a bit cleaner in that someone can tell what are the 4 main steps instead of the 20 or so tiny steps. But we still have some problems, which is that we're repeating the lines 9 through 12. And normally in programming, it's not a good idea to write something twice when you have the option to not repeat. Why is it not a good idea? Because if you have the exact same code written twice, then so several reasons. Suppose you have a bug, like for instance, I missed a semicolon here, and then to write the exact same code twice, I copied and pasted. So then instead of 1 bug, I now have 2 bugs, and more bugs is always a bad thing. And another reason you don't want to be copy pasting your code is if I change my mind, and like let's say I want to add specification, set the oven temperature to 400 or something. Now I have to make this change in 2 places. Whereas if I had written these 4 lines in a method and then just called the method twice, I would only need to make this change in that method once. So on that note, let me demonstrate how to group each set of smaller steps into a method. So, oh yeah, from the homework, I noticed some of you would define your other methods before the main method. Like let's say I'm making a make the cookie batter method. Hold on, let me turn off. Okay. I noticed most of you would tend to put your other methods before the main method, probably because in Python I said you have to define a function before you call it. And so you thought, okay, I need to define a method before calling in the main method. In Java, that's actually not necessary. You can put the methods in any order, and the main method will be able to call the others with no problem. So I'm going to put the new one at the bottom. Okay, so I'm going to group these first four statements into the method called making the cookie batter. And then later on, we'll go back to call the methods in the main method. Actually, let me copy over this code here for anyone who wants to follow along. Or I'm putting this in the meeting chat. And just a reminder, for now, all of our methods will start with public static void. And all our methods will also have no inputs. So after the method name in the signature, you'll just have an empty pair of parentheses. And then notice how I don't need to put lines 8 through 11 into another method, because later on I'm simply going to call the bake cookies method 2 times. So you can see the method names don't need to be grammatically correct, but they should be relatively short while also informing a human reader what the method does. Okay, so now that we've defined all the methods we need, we're going to call them in the main method. So the first big step, composed of 4 smaller steps, was to make the cookie batter. And now we can simply call that in the main method. So when you define a method, you need all these specifications, like what kind of method is this, what is the return value. But then when you call the method, simply just write the method name, in this case on its own line, and then followed by the pair of parentheses and any inputs, which in this case are none. And then we want to bake 2 batches of cookies, because here's the first one, and then here's the second one. So we're going to call bake cookies twice. And then at the end, we're going to add frosting and sprinkles. Now this program should have the same result as the first program we started with, except this new program has a lot better structure. Why? Because the main method looks cleaner. And why is it important that the main method looks cleaner? Because normally when somebody is looking at your code, like everyone is aware that the main method is the one that runs. And so what people will do is mostly look at your main method. And if they look at your main method and see these 4 meaningful method names, they already know what your program is doing. And then someone might not be too concerned how each of these smaller methods is made up of. And so Sometimes they just want to see the for method calls and get kind of an idea of what your whole program is about. This structure allows them to do that really quickly. So, okay, I'm going to paste this in the chat also. All right. So, just to sum up, here's some keywords. So, the methods we've been using so far are static methods, and they basically allow you to group together a few commands into one method that you can then call. And then when you're using static methods, this line where you write the method signature is called declaring the method. And then when you actually use the method, like running the method in your main method, is called calling. And the general syntax for declaring a method is to write the keywords public static in this order. And then void means this method has no return value. And then write the name of the method and a pair of parentheses and then an open bracket. And after all your statements, remember to close the bracket. Okay, let's look at, let me see. Let's look at another example. Sometimes you can have your methods calling each other. Like for example, in this program, you have the method message1, and then inside your method message2, you can actually call message1, and there is no problem with that at all. As you can see, message1 is called in both method 2 and also in the main method. And at this point, some students may have questions such as, oh, what if I define method 1 after method 2? Is method 2 still able to call the message 1? So we're going to try that. Okay. Hold on, copied over some extra stuff. All right, so as it is, this program runs fine. And the output is a bit convoluted, but we can see that there's no errors. Now, what if we define message 1 after message 2? Let's see if the code is still able to run. Hold on. Okay, well, we won't worry about the indents too much. So this still runs the exact same way. This is okay because in Java, all of the methods compile first and then they run. So there's not really the problem of the method hasn't been defined yet because the compiler had to already read through the entire program. However, you then might be asking, what if we have methods calling each other? What if message 1 calls message 2, but message 2 also calls message 1? We can see what happens. So this code never stopped running, or it wouldn't have stopped, because the methods keep calling each other. And sometimes you would do this on purpose, but currently we don't really have a use for that yet. And then, just to clarify, you may intuitively know this already, But when a method is called, for instance, on line 3 here, when we're calling method 1, the program jumps from line 3 to the first line of method 1 and then runs all the code in method 1, or I should say message 1, and then jumps back to line 4 to continue running in the main method. So that is how all methods work. Okay. Uh, and just as a good rule of thumb, don't create methods if you're using the method just to print one line. Okay, now we're going to do an exercise in which we draw this figure right here by breaking down our program into methods instead of printing each individual line. And I'll give you some hints along the way. So let me first copy this figure into the chat for anyone that wants it. Okay, I guess it didn't exactly get copied over in the same format. But first, I'm going to demonstrate creating a program that simply prints out every line. Now remember, to print out a backward slash, you actually need to put 2 slashes in the string. So here I have a poorly structured program. And just by the way, on the AP exam, they may have 1 or 2 multiple choice questions asking, why would we use a method? Why is that a good thing? Okay, but this prints out the figure that we want, so we are not done. Because we want to try breaking down this figure into methods. For example, you see some repeating shapes here, such as the top half of the stop sign. It's repeating 1, 2, 3 times. So if we define a method that's just drawing the top half of the stop sign, we can then call the method 3 times. And we can see Oh, I see. So the audio started cutting out like exactly 2 minutes ago, right? Okay, I'll go over the exercise that we're gonna do right now. So wait, what? Okay, so we basically just talked a bit about we're trying to draw this figure, but how can we break it into methods so that our code isn't so redundant? And my recommendation was to make a method for drawing this top half of the egg because this top half appears 3 times. 1, 2, 3. And then in our final code, we can simply call that method 3 times instead of having these 3 lines repeated 3 times in our code. And then please write a public static method for drawing the bottom half of the egg. And then some people might want to write a method for drawing this bar because they might argue, oh, this bar is repeated twice. And so writing a method and then calling the method from the main method would look more organized. But some people might also argue this bar is only 1 line, so I will just write this line as it is in the main method. That is up to you. So your job right now is to define 2 or 3 methods to draw these 2 or 3 things, and then call your methods combined with any necessary print statements in your main method to draw this figure right here. And let me know if you run into any bugs. And here's just an example of how you might start off one of the methods. I'll put this in the chat. And then when you're done, you can send your code on WeChat or in the Zoom meeting chat. Hold on, my screen share must have cut off at some point. Alright, so now I'll show you guys. Yeah, just make methods for drawing these 3 things. And then, let's see, I guess I will stay on the PowerPoint for reference. Just know that you can still see the parts that you're supposed to put into methods. Like a method for the top half of the egg, and then one for the bottom half, and then potentially a method for drawing this bar here.
I sent mine to WeChat.
Okay, thanks. Okay, so Joseph, that's a good start. Now do you want to put this into a method? So put some of the code you have into a method so that when you then call the method a few times, you can print out this figure. So for instance, I would make like my final result is to print out this whole thing exactly like it is. They have some strange details that you need to pay attention to, like where they have some extra blank lines. And then uh, in your methods, you can make one method that draws a top eggshell shape like this. And then in your main method now, you're going to call that top eggshell method a total of 3 times. And then make another method that draws a bottom eggshell shape, which you'll call also a total of 3 times in your main method. And then call those methods back and forth in the correct order, uh, combined with printing out any stuff necessary in the middle to draw out exactly this figure. And remember to reference the figure I pasted in the chat. Let me paste the figure again because the chat needs to reset. Because they do have, oh, oops. The figure does have some small details that they want us to match exactly. So be careful of that. Alright, Yo-Yo, this code looks more or less good. I feel like you might be missing a print empty line right after this print bottom half here, but that's not a huge issue. Well, since you have time, you can go back and fix that. Because you see, you're printing your top half, then your bottom half, and then they have an empty line here before the second bottom half.
Wait, can I see what I have to like print again?
Yeah,
At
sure.
at the PowerPoint.
Yep, this thing here.
Okay, thanks. Send mine to WeChat.
All right, I'll take a look. Okay, great, very good. And then I'm just going to put up somebody's code as a demonstration for people who are watching this recording. Let's see. Here we have Yo-Yo's code, which looks pretty good. Okay, and then this is an example of how you would break a complete program into methods for organization purposes. All right, so next we're going to talk a bit about expressions and variables. So I'm going to clear all of this. Okay, so as I mentioned yesterday when we were talking about what are the possible types of input for a method, oh, sorry, these are the types of return values for a method. In Java, there are some basic data types, which are the integers, doubles, and the strings. Strings does have to be capitalized whenever you are referring to that type because strings are a bit more complex. And I don't believe you ever need to know what's the limit for the largest integer you can create. So we're going to, in a moment, go over some of the operators like plus, times, divides, parentheses, and then just like in Python, the operators in Java also have a certain precedence. So what goes first and then what goes last. And then together, the uh, data types combined with operators form expressions. And every expression will have a result. The result will also have a certain type. For example, if I did if I wanted to print the expression, just a really basic 1 plus 2, then the result will also be a type int. Uh, okay, so one interesting thing to note is in Java with string concatenation, you can concatenate integers and doubles onto strings. So, wait, let me make this text a bit bigger since we have smaller code now. Let's say we want to say hi and then plus the number 1. Hold on. Okay, I'll just use the example they have here. So, first, what if I didn't use these parentheses? Then what would happen is you get hi and then 2 ones and then u because uh, in addition, we're going from left to right. So the computer will first do this step and then do the second addition step and then finish off the entire expression. And so what will happen is every time we try concatenating an integer to a string, integer will turn into part of the string. So the result will be high 1 like that. The integer is simply gone. There's no longer anything of an integer type in here. And so then when we try to concatenate another 1, then we are simply adding 1 as a string character to the end. However, if we put parentheses around the 1 plus 1 in the middle, then the 1 plus 1 will be done first. And since the 1 and the other 1 are both integers, this thing in the middle will become a 2 first, and then the 2 will become part of the string. So these are just some quirks that you have to remember, because on the AP exam, they'll very often give you questions and then ask you what's the output of this program, and sometimes it can be really specific like that. Okay, so then let me quickly go over the operators, although they are the same as in Python. You have your add, subtract, multiply, oops, multiply, divides, and then your parentheses around something would cause that thing would be done to be done first. And then the percent symbol is the modulus operator. So, for example, let me do just one example of the modulus. Let's say we're printing 45. Let's go with 15 mod 3. The result of this is 0 because what the modulus does is give us the remainder. So if we did 15 mod 4, then the result would be 3 because 4 times, well, actually, I'm going to do a different example because 4 times 3 is 12, but that has nothing to do with this 3. Not a great example. Okay, the result is 1 because 4 times 6 is 24, and then there's 1 left over until 25. And then you can try out floor division. Oh, wait, but you can't do floor division with the 2 division symbols because that's how you make a comment in Java. And then something to note is that when you are dividing 2 integers, like let's say I want to see 25 divided by 4, the answer will automatically be rounded down. Because 25 divided by 4 is actually 6 point something. But because you are dividing an integer by another integer, Java automatically converts your answer to an integer type, which means any decimal information is lost. However, if either your divisor or your dividend are a double, then the decimal places in the answer will also be preserved because Java will recognize the answer as a double type. And this works if either one or both of these numbers are doubles. Okay, so with that being said, we have exactly 6 exercises and 3 students in attendance, which is perfect. I'm going to ask certain people, and here I'm just going to write down who I'm going to ask. So be prepared to tell me the answers. So whenever you're ready, or I guess after a few minutes, I'm going to ask Joseph for the answer of the first question. And all of these are just telling you to simplify the expressions down to one integer or double, whatever it may be. You can also put your answer in the chat once you come up with it. And each person only needs to do their two answers.
I got 6.
For which one? First one?
First one, like I like put in my code.
Uh, Let me see.
Is it supposed to be 6?
So 12 divided by 5 would be 2 point something, which will round down to 2. And then 8 divided by 4 is exactly 2. You should have gotten 4.
Well, like
Wait, let me see.
I just
Maybe I made a mistake.
should I like put like 12.0?
Oh no, just keep the expression exactly as it is. Yeah, should be 4.
No.
But also for the second one, try to guess it first without putting it in the code. And then you can double check. And then you're free to use scratch paper or whatever. But yeah, sometimes they put these integers on purpose, and they are going to lose decimal places in the answer. They're just testing whether you know what will happen. Okay, let me see. Now I'm going to run all of these to check your answers. So first one is 4, and then okay. All right, Yo-Yo, both of those are correct. Good job paying attention to the type of the output. Even if it's a whole number, sometimes the output is still double. Very good. And then Lawson, let's see. For the last one, you were supposed to get 1.75. So let's work through how this might be 1.75. So division comes before addition. This is just like
Mm.
in real life math class. So 4.5 divided by 3 is, well, it is 1.5, but, okay, actually, no, but since 4.5 is a double, so the 1.5 will be preserved with the decimal place. And then 1.5 divided by 2 is in fact 0.75. And then 0.75 plus 1 will be 1.75. All right. So it should have gotten 1.75 for the last one. And then Joseph, let me know anytime you're done with number 4. No need to rush. And I'm just going to tell you guys, you have to do these by hand because there are a few, at least multiple choice questions on the AP exam asking you to do these by hand. And did you know on the exam you don't ever get to test your code? There's no place for you to run a program. You have to write it all from memory, and then that's why you can't run these through a program right now. Or that's why I'm not letting you. Okay, since it is around the middle of class, let's take a 2-minute break until 9:40. And then Joseph, remember to put the answer to number 4 in the chat or just tell me whenever you're done.
It's eight.
Huh?
Is it eight?
Let me see. Sorry, your audio is cutting out a bit. But since you're done, I'm just going to put this in the program and then you can see for yourself. Okay, did you get 3?
Oh, no.
That's alright, let's take a look. So, uh, again, the modulus is a bit of a weird operator. It's actually asking for the remainder, which is kind of weird.
Oh, I
So,
was using the division sign.
that's okay. So yeah, 42 divided by 5. Well, 40 times, sorry, 5 times 8 is 40, but then there's 2 left over. And so 42 mod 5 is 2. And then 3 times 5 is 15, but there's 1 left over until 16. So 16 mod 3 is 1, and then 1 plus 2 is 3. Okay, not bad, everyone. And it is 9:40, so let's do the next thing. Let me just delete those for now. Okay. All right, we have some more expressions, this time with string concatenation. And oh, actually, with the first one, there's something I have to demonstrate, which is that, so we've already seen how if you try to concatenate an integer to a string, the integer will turn into a string. Right, so you added 2 and you added 6. However, if you did things in the opposite order, put the integer first, you get a different result. Because as soon as a string appears, everything added after that turns into a string. However, before the first string appears in an expression, numbers are just going to add together normally as numbers. So 2 plus 6 is 8 because no string has appeared in this entire expression yet. But the moment you add a string, like CSE 142, then the 8 goes into the string, and then everything afterwards is treated as a string. So that is a pretty important thing to keep in mind. I'm going to, let's see, do they have more exercises? No. Okay, I'm going to assign exercises. So for your first one, what is the output of? Okay, I'll just write it. Mm, okay, and then uh, just so that everyone gets more practice, I'm going to have all three of you do all three of these exercises. And the last one is kind of a trick question, which I'll explain later, but just try your hand at all three exercises for now. And then send me the answer in Zoom or WeChat when you're done. Or I guess WeChat's not necessary because you're just calculating this in your head and then telling me a single number or string.
For the first one, we got
Mhm.
2.5 hello.
Okay. Yeah, that is correct.
For the second, I got 13 hello. 13.
Interesting. We'll take a look at that one, but after everyone else is done.
好，我想上厕所了。
All right. Answer received from Yo-Yo. We're gonna wait until everyone's done, and then especially we will take a look at what happened in the last one. Oh, okay. And then, all right, Joseph, do you have an answer for the last one? Don't worry, we're gonna
2
take a break.
Java is cool too.
Okay, close. So, all right, let's take a look. So for the first one, everyone got that right. I'm not gonna talk about it. And then, for the second one, so, uh, if I had put parentheses around the 6 plus 7, then you would get 13 hello 13. However, why is it different without the parentheses? Well, So the 7 plus 6 at the start still turns into 13, but then the 7 and the 6 at the end just get added as a 7 and a 6. Why? Because one way you can think about it is we're doing addition in order from left to right. And so we're doing the 6 plus 7. Now, when we're looking at just the 6 plus 7, no strings have appeared yet, which means we're not even doing string concatenation, just regular addition. And then what's 13 plus hello? Well, our first string has appeared. And so since there's no logical way to add a number and a string, then Java interprets the plus as concatenating. You're combining, chaining together the 13 and the hello into one string. And then from then on, we do the operations from left to right, which means every operation now contains a string in it, the 13 hello, which means every number is added on as a string concatenation. And now our last operation is also restricted to a string concatenation, not to regular addition, because the first part here is a string that we have. So yeah, just think of an expression like this as you're adding everything from left to right. And so what happens when one of those things starts becoming a string? The string turns everything else into a string. Okay, and then for the last one, this is interesting because you might say, okay, oh, hold on, I missed the two. All right, so if you did paste this into Replit, you get a hint that there's an error, but let's look at why. So in PEMDAS, subtraction and addition are both at the end, but they are on the same level. So normally, if you have a long math expression with both addition and subtraction, you would still go from left to right. So 4 minus 2 first becomes 2, and then 2 plus 5 becomes 7. And same thing here. So let's see what happens. 4 minus 2 equals 2. And then, actually, let me write it out like this. So we're doing all the expressions, all the operations in order from left to right. Okay, like that. So first, 4 minus 2 equals 2. And then 2 plus Java is cool becomes a long string like that. And then Java is cool plus 4. Well, that is a case of string concatenation. So the 4 got concatenated to the end. And now, we are left with a string minus the number 2. And in this case, there's no such thing as, oh, let's remove this 2. Java is not going to recognize that as your intention. And so this is simply a bug because you can't use a minus symbol with a string for any reason. And if you do run this, you'll get an error. All right, let's take an actual break for 5 minutes. So we'll be back at 9:55. All right, now we're going to talk real quick about variables, and then the rest of the time will be for your homework. Okay, so let me start this off just with the demonstration actually. Hold on, let me share my screen. Oh, okay, it was. Okay. All right, so remember how in Python, the way you define a variable is to say variable name equals variable value, putting the name on the left and then the value on the right. And then whenever you want to modify that variable, you simply write the exact same thing, except different value as needed. Well, in Java, things are a bit different, a bit more complicated. First, when you are defining a variable for the first time, you must state the type of the variable. Now, I must have mentioned this yesterday, but just going over it again because you need this for your homework. In this case, our type is an int. And oh, oops. So first write the type of the variable, then the variable name, then the equals, then the value. And let me just comment out these fake lines of Python code. And of course, you need a semicolon at the end of defining a variable, because in Java, every complete statement needs a semicolon after it. And then when you want to modify a variable, though, now this I did not go over yesterday, then you do not need to state the name of the variable again. Sorry, you don't need to state the type of the variable again. Simply modify the same way you do in Python. And why do you not need to state the type again? Well, because in Python, when you modify a variable, you can change it to a different type entirely. And that's perfectly legal in Python. However, in Java, you can't do that. So there's no way to say, oh, I want to change this variable now to a different type. See, we have an error here. X is already used, and you cannot change X to a different type, which is why you don't need to state the type again, because the type has to be an int. All right, so this also goes for the double type. Now, you may notice how I defined X as a double, but then I wrote its value as an int. Why is there no error? Because Java does a little bit of automatic conversion from 12 to 12.0, making this in fact a double. You could experiment with, what if I try to define an int variable, but then its value is a double. Now this does produce an error. Yeah, even if it's 12.0, this does produce an error. However, something as specific as that would not be on the AP exam. I've never seen on the exam what happens if you define a double variable but make its value an int. Okay, so now, mm, let's talk about what does declaring and initializing mean, and then after this we'll get to your homework. So in Python, when you're defining a variable, there's one step. We just call this step defining. However, in Java, when you're defining a variable for the first time, there's two steps. The first step is declaring the variable, and then the second step is initializing. Declaring means, hold on, what's wrong here? Okay, I'll take a look at that later. Declaring means to state the type of the variable. And then initializing means to assign the variable to its first ever value. And right now you are doing both things at once. The double x part is declaring, and then the x equals 12 part is initializing. However, in Java, it is perfectly legal to do the declaring and initializing on separate lines. You can first say double x, just like that. This means let there be a variable x with the type double. This is declaring. And then on the next line, let's initialize x equals 12. Note that if you do choose to do this, you have to declare before you initialize, and you have to do both before you use the variable. And we'll come back to this way later in the course when you're creating your own class. You sometimes have to declare and then initialize in an entirely different place. Okay, so any questions on creating a variable, using a variable, declaring and initializing?
Yes.
Yeah?
Um, what happens if you print X after you declare but before you initialize?
Okay, great question. Let's see what happens. So we have a hint that something is gonna go wrong. Let's see. So variable x might not have been initialized. They mean definitely not. They're just trying to be polite. So yeah, that's what happens. Okay. Any other great questions? All right, and then real quick, I'm just going to demonstrate that if you have, say, a string, then you can use the variable name in string concatenation, which I say is the main use of string concatenation in a practical sense, is for combining known strings to variable names. Oh, sorry. Wait, I wrote the wrong thing here. Yeah, like in this example. And if in this entire course you're only going to remember 2 official vocabulary words, it should be declaring and initializing. Okay, so for your homework, since it's first week and you guys worked so hard on the homework yesterday, I'm going to give you a slightly easier homework, which is actually something you all did in Python. So remember the Mad Libs thing. You're going to do that again, but in Java. In this case, just keeping everything in the main method so that we can get used to declaring initializing variables. So in your code, you're going to have some string variables that represent the words that people have to fill in. For example, if in your Mad Libs you first have a verb and then maybe another verb, you can call these verb 1 and verb 2. And then an adjective or something. So you are going to go find your own Mad Libs online. And then if you find one that's too long, feel free to just use 2 or 3 sentences from it. And then in your code, you are going to set up an area where the user can fill in the variable values, which would be like the equivalent of them telling you the words to write in the story. And then for bonus points, use a comment to denote that this is the area where you fill in the words.
Can we create our own Mad Libs?
Yeah, sure. That would be great. And then in the end, use your print statements to print the given text, and then uh, insert whatever word the user typed, and then proceed with the given text as the same way it is in the Madlib. And you might use multiple print statements. You might use a \t so that you can indent the start of your story, which would be nice. That is all up to you. And if your story contains a quotation mark, remember to use your escape sequences. Okay, and actually, I just thought of one last thing. Remember how in Python, your strings can either have double quotation marks or single quotation marks? Well, in Java, that is not the case. Suppose I try surrounding the first string in single quotation marks. Well, actually, let me paste this reference in the chat and then just clear all the code entirely for this next thing I'm going to say. Okay, so can you use single quotation marks for a string in Java? No, and that is because in Java there is another data type called a char, which stands for character, and a character consists of one singular character, and the character will be surrounded in single quotation marks to differentiate it from a string. So you can have one character string, but that is fundamentally different from a character. These two things are different data types, and that's why you cannot use a single quotation mark on a string in Java. All right. Any questions on the homework or anything from class?
So like, how do you like input again?
So I have not taught you to input in Java. You don't need to do that yet. For now, just set up an area in your code where the user is going to go in your code and fill in these words. Something like that. Pretending I'm the user, I might do this, right? And then soon we will learn how to actually input over on this window here. Okay, so there are no other questions. The remaining 20 or so minutes are for you all to work on your homework. Maybe you can finish your homework and have nothing to do this week. And if you weren't done with yesterday's homework, no need to feel bad about it because I know it's only one day, it's a really short time, and you might have other activities. But make sure to get done with yesterday's homework and put that in WeChat also.
So like I tried to like sort of make the user to um in time equals like the user will type it, but I want to put nothing there, and it has an error.
So wait, let me see.
I'll
Oh,
send it in WeChat.
okay, sure.
So like I put 10 there because like if I put nothing there, it's an error.
Yeah, that is true because you can't just put nothing. And the workaround we had for that with a string was to just put an empty string, which still uh, completes the uh, initializing. Well, I guess you can put like a default value. What do you think can be a default value for an int? How about 0?
Sure.
Yeah, that would work.
Well, I put 10.
Yeah, that also works.
Can you check in like WeChat?
Okay, I'll take a look.
So is this our homework for today?
Yeah, that's the homework for this week. Because it's the first week, so nothing too much.
Okay.
All right, very good, Joseph. If you want to leave early, you can do that.
Okay. Bye.
Bye bye. Yo Yo, I see your homework in the chat. Very good. So if you want to leave early, you can also do that.